Bismillahirrahmanirrahim. Welcome to the new lecture of data communication, which is the fourth part of your chapter 3. So today we are going to study about data rate limit. Data rate, yeah, bit rate. So both are the same thing. So bit rate or data rate mean you can find the speed of your data, speed of your internet, speed of your transferring. This is called data rate or bit rate. So the most important thing in a data limit is that how fast you can send your data per second. Yeah, how fast you can send your bits per second. So that's called data rate. So data rate is depend on your speed of your data, how you can transfer it, in which speed, maybe more than, maybe less, maybe whatever you want. So three important factors which is depend on the data rate is the bandwidth available. If you have a more bandwidth, so a lot of data you can be transferred it. So first thing is the bandwidth availability. The second is the level of a signal. So as you know that about the level of a signal, you study that when a number of level and a number of bit is going to be increased, so number of level is going to be increased, number of bit is increased, number of level increase. So you know about the formula of, if you remember it, bit was equal to log of 2L. So it's depend on the level of a signal as well. So the third most important thing is the quality of the channel. So what is the quality of channel mean? Is the channel is noisy or without noisy or noiseless channel? Noiseless channel mean there is no noise. So three more important factor which is depend on the data rate is three: bandwidth availability, level of a signal, and quality of the channel. So in this lecture we will study about a noiseless channel. Noiseless channel which is explained by Nyquist bitrate, and also study about noisy channel which is explained by Shannon capacity, and the third is using a both limits. So the first thing which we need to be understand about, so the capacity of a system, so it's just a concept. So capacity of system is the bit rate of a system increase. Bit rate mean data rate increase with the increase in the number of a signal level, as I told you before according to the formula. B is equal to log of 2L. Okay, same formula is applying everywhere, log of 2L. So increasing the bit rate is based on the number of level. The second is a symbol can consist of a single bit or n bit. It can be one bit, it can be more than one bit. N bit mean in number of bits, how much you want it, so it's based on it n bits. So that is number of a signal level. So how you can find number of a level? So 2 raised to power n is your bits. If you have a 1 bit, so n is equal to 1. So 2 raised to power 1 is 2. It means you have a 2 level. If you have n is equal to 2, so 2 raised to power 2 is 4. So it means you have 4 and so on. So it's a formula, just apply on it. You can be find out the levels, and this is the formula how you can find the bits. So as the number of a level goes up, the spacing between the level is going to be decrease, and also increase the probability of an error occurring in the, because the spacing between the level is going to be decreased, so there's a chances of overlapping, interference, etc. So due to interference and overlapping, so maybe your signal is going to be, or your data is going to be bit error. So this was just a concept for you guys, need to know about it everywhere. That's increasing bit rate is dependent on the signal level, number of bits, level, and so on. So coming to the first important thing about Nyquist theorem. So Nyquist theorem is talking about noiseless channel. So according to Nyquist theorem, so Nyquist gives the upper bound for the bit rate. For what? Bit rate. Keep in mind, for the bit rate of a transmission system by calculating bit rate directly from the number of a bit in a simple and the bandwidth of the system etc. So Nyquist theorem, the most important we need to be know about this thing. So Nichols theorem stated for a noiseless channel. Noiseless channel means there is no noise. So the capacity, yeah, the width capacity is equal to 2b log of 2 raised to power 2n. So 2 raised to power means L. So you can also be write like this, that C is equal to 2b. B is a bandwidth. B is a bandwidth and log 2 L, because 2 raised to power n is equal is level. So C mean capacity in bit per second. This is capacity in bit per second. So it means you are what we can do in a Nyquist theorem, we can find the data rate in a bit per second and be the bandwidth. So just remember this equation and know about what factor is needed for what kind of a thing. So Nyquist theorem is based on capacity in a bit per. So now we have some example 3.34 from our book. So it's about Nichols equation. So he said, consider a noiseless channel with a bandwidth of a 3000 hertz. What is the bandwidth? Bandwidth is 3000 hertz. Transmitting a signal with the 2 signal level. How many level? 2 level. The maximum bit rate can be calculated is, so you have a formula. So C 2B log 2L. So you have a bandwidth, okay, put it out here. You have a 2, you have a log 2 and 2 level. So 2 will be 1, so 3 multiplied with 2, it should be a 6000 bit per second. Simple multiplication, mathematics, okay, just simple. What is the bit rate? What is the bit per second now? 6000 bits per second, okay. But keep in mind, in a noiseless channel there is no noise, okay. So another example 3.35 from a book. Consider the same noiseless channel transmitting a signal with a 4 signal level. For each level we send 2 bits, okay. The maximum bit rate can be calculated is, so again the same thing, bit rate, you have a bandwidth 3000 log 2, how many level you have? 4. So 2 raised to power 2 will be 4, so 2 will become here 3000 multiplied with 2 6, and this is 2 raised to power 2, so 2 will become outside, and 2 log of 2 with 2 is 1, so it will be 12,000 bit per second. Another example, so now this is important one. So we need to send 265 kilobit per second. How much? 265 kilobit per second. We already sending a bit rate now. So put the bit rate here. Okay. Then over a noiseless channel. Keep in mind, if there is a noiseless channel, then you can use this formula. Otherwise, you cannot. So a bandwidth of a 20 kilohertz. So you can put the bandwidth here. So how many signal level do we need? So what we need to find? We need to find a law. We need to find a level. So again the same formula will be applied here. Finding a level from this formula. Taking an anti-log here, so L will be 2 raised to power 6. So it will be 98.7. One thing keep in mind, we always need a level in 2 raised to power n. Okay. So if you think about this, so it's not a 2 raised to power n, so it may, so we can increase this or we can decrease this number, because if you take 2 raised to power 7, so 2 raised to power is 2 multiplied with 2 4, 4 multiplied with 2 8, 8 multiplied with 2 16, 16 multiplied to 32, 32 multiplied with 2 is 64, and 64 multiplied with 2 is 128. So it can be so it can be 2 raised to power 7. We can be increase it or we can be reduce it. So it's depend on the condition. So 2 raised to power 7, it can be 128 or it can be 64 level. Okay, because we always need in a 2 raised to power n formula. So since the result is not a power of 2, we need to either increase the number of a level or reduce the bit rate. So if we have 128 level, the bit rate is 280 kilobit per second. What does it mean? Again, so your bit rate is equal to, so you have a 2, okay, then what is your bandwidth? So the bandwidth is equal to 20, and then the formula log of 2L. So how many level you have? 128, so it can be 2 raised to power 7. So 7 will come out here, so it may be 7 here. So 2 multiply with it's just 20. Multiply 7 and log of 2 with 2 is 1. So it will be is equal to 2 multiply with 20 is 40. 40 multiply with 7. So it will be 280. So 280 kbp as per second. Why we are not using it? So it can be log 2 and 2 because what 2 raised to power 7, 7 is coming to here, so log 2 it will be equal to 1. So 280 kilobit per second. So for a 64 again it's 2 raised to power 6, so 6 will be here, then it will be 240 kilobit per second. So this is just a simple mathematics. Okay. So the conclusion of this question is mean that when you are going to be reduce the number of levels, so it means you are reducing your bit rate. So this is the basic conclusion. So now coming to the Shannon theorem. Shannon theorem about a noisy channel. Keep in mind noisy channel. Okay. So one thing about the Shannon theorem is Shannon theorem gives the capacity of a system in the presence of noise. In the presence of noise, I told you it's about noise channel. So again, C is equal to B log of 2 1 plus signal to noise, because we are talking about noise, so we need to have a signal to noise ratio. So coming to the example. So just keep in mind this formula for a noisy channel. So consider an extremely noisy channel in which the value of the signal to noise ratio is almost zero. Signal to noise ratio is zero. In other words, the noise is so strong that the signal is fine. For this channel, the capacity C is calculated is so C is equal to B log of 2 1 plus signal to noise ratio formula. So B is equal to log of 2 1 signal to noise ratio 0. So B log of 2 with a 1. So it's going to be 0. Okay. So what is the capacity? Capacity is going to be 0 because your signal to noise ratio is 0. Signal to noise ratio mean one thing keep in mind. Signal to noise ratio mean that your signal divided by noise. So when your signal to noise ratio is almost 0, it means your signal is going to be 0. So when your signal is going to be, that means there is no capacity. So that's why we are saying it's proved by this one. Okay, because noise is too much. So when a bigger value, so in a signal is small, so a small value is divided by a bigger value, so your answer will be in 0.00123. So it's near to be a 0, so that's why we are saying that your capacity is going to be 0. So this is the basic way of basic way of a noisy channel. So this in this way you a lot of noise will be available in a signal. So another example, we can calculate the theoretical highest bit rate of a regular telephone line. A telephone line normally has a bandwidth of a 3000. This is a bandwidth. So the signal to noise ratio is usually 3162. Signal to noise ratio is this one, your bandwidth is this one. So for this channel, the capacity is calculated is, so capacity again, you have a B, okay, put out, formula will be here, 1 plus, you have a signal to noise ratio, just take calculator, simplified it, so your capacity is going to be 34 kilobit per second or 34,860 bit per second. Okay, so it just means that the highest bit rate for a telephone line is 34.8 kbps. If we want to send the data faster than this, so we can either increase the bandwidth of the line or improve the signal to noise ratio. So this is more important now. Increase the bandwidth, I told you in the first. So if you increase the bandwidth, so you can be transfer your data faster than this one, or you can improve your signal value. You can improve your signal to noise. Once your signal to noise ratio is good, is greater, so your bit rate is going to be good. So coming to another example, example 3.39 from a book. So he said that the signal to noise ratio is often given in a decibel. So you know about a decibel that we always take a signal to noise ratio in a decibel, or the value of a signal always be in a dB or decibel. So assume that signal to noise ratio in a dB is equal to 34, and the channel bandwidth is, so bandwidth is available, signal to noise ratio in a dB is available. So the theoretical channel capacity can be calculated as, so you have this formula, signal to noise ratio dB. So in a formula you don't have a dB, you just need a signal to noise ratio. So first you need to transfer signal to noise ratio dB into signal to noise ratio, simple signal to noise ratio. So this is the formula. Signal to noise ratio is 10 log of 10 with the signal to noise ratio. So just you have a 36, put out 36 here, okay, then it's just simply like this. Signal to noise ratio, it's 36 10 log signal to noise ratio. So 36 divided by 10, and it will be log of, this is base of 10, so log of, it can like here 36 divided by 10 is equal to log of 10 signal to noise ratio. So it can be 3.6. 3.6 equal to log of 10 signal to noise ratio. So when you are going to be improve the replace this one, so it can be 10 raised to power 3.6 and signal to noise ratio. So simple calculation, and so you get a signal to noise ratio. So your signal to noise is 3981. So just apply the formula, the Shannon capacity. So C is equal to B log of 2 1 plus signal to noise ratio. So you have a B which is equal to 2 megahertz. So mega is 10 raised to power 6 log of 2 and signal 1 plus signal to noise ratio. Just add it out. So your result is this one. So simple way of solving a noiseless and a noisy channel using a Nyquist equation or using a Shannon capacity. Okay. So keep in mind these two concepts, which is more important, because each and every kind of a question regarding data rate or a base or a transfer data is according to Nyquist or a Shannon capacity. So one thing more, example 3.40, for practical purpose, when the signal to noise ratio is very high, signal to noise is very high. So for practical purpose, he's saying practically like ideal case. In ideal case, we have a signal to noise ratio is too high, but in real case, there's a noise. So when there's a noise, it means we will have a some disturbance in our signal, and we need to be correct it out. So we can assume that signal to noise ratio SNR plus 1 is almost to be SNR, because SNR is too much. When SNR is too much, so when you add 1 with the too much, so again it will be a too much value. So this formula is going to be like this. So C is equal to B multiply signal to noise ratio dB divided by 3. This is just for our ideal case. Keep in mind, this is for ideal case. This is a formula. So for example, we can calculate the theoretical capacity of the previous example, like example number this. So where we have a 2 megahertz bandwidth, where we have a signal to noise ratio dB 36, and also we have a 3. So if you divide it, so it could be 24 megabit per second. Again the same one, because one it doesn't matter there, and it just simply directly use your SNR in a dB, no need to be transfer. But if you are going to be use this formula, so you need to be transfer dB into signal to noise ratio, simple value. Okay, so that was basically a concept regarding this one. So coming to another example, again we have a channel with a 1 megahertz bandwidth. Again we have a bandwidth. Signal to noise ratio for a channel is 63. What are the appropriate bit rate and a signal level? Bit rate and signal level. So first we use the Shannon formula to find the upper limit. So Shannon is, so you have a B, you have signal to noise ratio, so your bit rate is 6 megabit per second. So simple one. Okay. So we already find the bit rate. So now we are coming to find the level. So after finishing this question, so you will know about two things more important. So first of all, see here. So we one thing you guys need to be in mind. So we always have a limit, upper limit and lower limit of a bandwidth. So let's see, your bandwidth was 6. For let's see. So it's your upper limit, and so we are saying that your lower limit will be 4. It can be 2, but we can say it's a 4. It's your lower limit. It's your upper. So we have two limits. So limit between 4 and 6. So the Shannon formula gave us 6 megabit per second, the upper limit. Okay, so for a better performance, we choose something lower. So 4 megabits, for example, then we use the Nyquist formula to find the number of a signal level. So you have a formula of a Nyquist where you have a bit rate, so your bit is now is 4 megabit per second. 2 is in your formula, and so you have a bandwidth of 1 megahertz, and again you have a formula log of 2L. So your result or number of a level is 4. It's just simple mathematics calculation. So your number of level is 4. So now the more important thing I'm telling you, so that's the important thing which I want to tell you, that the Shannon capacity gives us the upper limits, and the Nyquist formula tell us how many signal level we needed. So just keep in mind that Shannon is telling about the upper limit and the Nyquist is telling about the number of level. So it was your lecture for today, so you guys can be watch it out. If you guys find any question, you can contact me. So I just was a bit faster in numerical because just numerical and mathematics, so that's why. So hope you guys find it well. Thank you for your time. See you in the next lecture.